Preon stars. Preon stars are basically the same as neutron stars. So I am going to tell you about neutron stars, and then I'm going to talk about Preon stars and why they aren't like neutron stars. Neutron stars are formed when massive stars die. If the star's mass is about 9 masses of Sun to 20 masses of Sun, then the remnant after the supernova will be a neutron star. This star is formed with neutrons and is incredibly dense. Imagine your whole head squeezed into the thinness of the human hair, or Mount Everest into a sugar cube. Some neutron stars rotate so fast that they emit beams of radiation, these are called pulsars. And they are so powerful that they make it look like the neutron star is flashing up and flashing all the time, as if there was a light on it and with really bright luminosity, and it all the time kept turning off and on and off and on like that. Except this is not easy to see because most of the time it will go super thin because of how fast neutron stars rotate. Some pulsars can rotate over 500 times a second. The fastest ever rotates an incredible 716 times a second. That means that for every time, everywhere on the neutron star, a point on the neutron star will be moving around at the fifth of the speed of light, which is crazy. So now the Preon star. Now, for Preon stars, we have to understand quark stars. They are same to neutron stars, except they are much denser, and they are so strange that inside them strange matter can form. But I'm not going to talk about that. So, for Preon stars, they are denser than neutron stars and denser than quark stars. But how dense are they? Well, really dense. They're about 100 septillion. Their density is about 100 septillion kilograms per meter cube, which is crazy. It means compressing Mount Everest into the size of, well, something like, it will mean compressing Mount Everest, our dear Mount Everest, into the space of not just a bacteria, but Mount Everest in a virus, which is like crazy. So with this high density Preon star, what makes it special? The density in a Preon star is so high that it is really going to be stranger than even strange matter. In this thing, the density is so strong that even strange matter has to come to an end and can form the bottom quarks. However, top quarks are really hard to form. However, could they form in a Preon star? Yes, in a core of the Preon star. I know it is very small, maybe the size of a salt cube, but the core of the Preon star, in the core of the Preon star, it's so compressed, the density, that the that basically top cores can form in the core, and the core of Preon Stars can reach temperatures past 100 trillion degrees Celsius, degrees Kelvin that is, which is incredibly hot. So they have a really strong magnetic field. Because they're so dense, they can have the mass of the sun they must be really massive and really small, basically. So dense that the density is unimaginable. I mean, so is the gravity. If you were standing on a Preon star and found a way to protect yourself from all the harsh conditions, then still you can't get rid of the fact that you will be weighing you'll weigh a whopping at least 3 to the power of 3 sextillion if you are 30 kilos. And since I'm 8 kilos or something like that, I will be something like 2.8 sextillion kilograms on a Preon. And what's more, we can't defend against the extreme heat at the surface even. For comparison, I will give a solar tornado, but that is not going to work out because it's only 2.8 million degrees Celsius, and I think that the temperature of the Preon star at the surface temperature of the Preon star should be around, I think, say something like over 1 billion degrees Celsius. Yeah, over 1 billion degrees Celsius. Maybe 500 million degrees Kelvin at least is the top temperature of a Preon star, and for comparison, a neutron star is at least 1 million degrees Fahrenheit. That's 600 million degrees Kelvin. So at 500 degrees billion degrees, no, it is something like 500. So the neutron star is the 600,000 degrees Fahrenheit, about 600,000 degrees Kelvin or 1 million degrees Fahrenheit, and the Preon star is 500 million degrees Kelvin. Even at its surface, that too at least. So yeah, Preon stars are really disastrous. In fact, they are so powerful that they can gobble up whole stars. The only thing that could be denser than a Preon star is a black hole. But other than that, nothing is denser except the Planck density, which is dense enough that any density above it and the object you are in order to represent the density will basically be a black hole. But that's about 10 to the power of 96 kilograms per meter cube, and is crazy. So it's so crazy that I won't be